Start recording. Okay. No, I clicked on the wrong thing. Go away, word. Oh, man. Man. This pointer thing is absolutely destroying my computer, though. Do you see this stuttering? Yeah. Woo! I'm not sure it's going to work out long term. Okay. Now.
So is this little thing projection on that?
Yeah. Not projection. Hey, wait, what you doing, man? Now there's going to be a clip in the video of Antavis's hand just like over the big part. Oh no, I guess this is the top right part. That's not too bad. Okay, we'll let you get away with it this time. Okay, so we're going to download Cookie Monster. Chapter 4 data files. Cookie Monster. Oh, this is Excel 2016, I guess. Cookie Monster. Go away.
Whoa. I don't know Cookie Monster.
It's a whole lot of data, isn't it? So let's just see. Control right. Better yet, control. Okay, control shift. There are. Wait. It's not even. Oh, is it because the no editing's turned off? It broke my selection. How dare you? 50 variables and 20,000 rows. Damn. That's a few, isn't it? 20,000. Now, of course, remember, in real life, you're more likely to have 20 million. But it starts to feel a little more real, huh? It's not 12 anymore. Okay. So, let's see what we're going to do. We're going to look at, so now again, I'm using the Cookie Monster file. This is one of the homework problems that you could work on if you wanted. So part of the point of this, by the way, is I'm showing you that if you want more practice, you can just open the textbook and you look for something that sounds like what we're doing. So in this case, this is question 17. It's not one of our homework problems, but you could, so you can look it up if you want. So this is the file Cookie Monster Inc. Cookie Monster Inc. is a company specializing in the development of software that tracks web browsing history of individuals, hence cookies. Get it? It's a pun, because instead of like Sesame Street, it's web cookies. Oh, it's adorable. So a sample of browser histories is provided. A sample. Because of course, how many browser histories are there? Well, I mean, how many devices are there, right? So just my desktop at home, I've used, how many different browsers are there that I've tinkered with from time to time? So I have an Edge browser history, I have a Chrome browser history, I have a Firefox browser history. I think I opened Opera by accident once. So at least 3, and that's one computer. I have this laptop, which is another set of things. I have my phone, which is more browser histories. So just I alone have at least like 8. So there's a lot. Now, this is an example. So we have a bunch of places, websites that we might have gone. So the question here is, these are all binary. It's a binary binary matrix listing whether a particular website was visited in a given browser history. So the first few options are The Every Girl, which I'm assuming is a magazine. Someone want to tell me what it is?
Never heard of it.
Never heard of it. I know what 9gag is. Wikipedia, Facebook, Amazon, CNN, MSN, Tumblr, Blogger, Pinterest, Craigslist, IMDb, Babbel, Flickr. I've heard of most of those. About, oh, there's an about.com, YouTube, WordPress, Blogspot, right? And so on. There's more. So, did an observation, did an element view this particular website? Was it found? Now, we can't tell. Was this person, were they an influencer? Did they visit their Instagram page like 70 times a day? Or did I open Instagram once because I got redirected on accident? Can't tell. We just know, did they go there or not? Okay, that's what close. So, what we're going to try to do is find how these websites are related. Meaning, if an individual visited one of these websites, how likely are they to have visited another one of the websites? That's the question at hand. So, this is a problem solved by association rules. Okay, so, association rules. Over on the right, by the predicts that I'm telling you to avoid, we have association rules.
Go to data mining?
Yep. Association rules. It's my Sean Connery voice. Association rules.
And then what?
Click on associate, association rules.
Where is that at?
On the right, by my cursor.
Associate. I was looking for association rules.
Ah. Tricky. Did yours explode too?
Yeah. It had the screen call pulled up, and now it's just like the.
Oh, good. My favorite. We're having an experience up here. Okay, so what you see here is largely informative. So it's going to tell us, okay, we've got 2,000 minimum support for something that's interesting. And oh, that information I just looked up a minute ago. Oh, it's right here. Isn't that convenient? 20,000 rows, 50 columns, which is observations and variables. My first row contains headers. This data is in binary matrix format, meaning it's different binary variables for for a list of things. And then there's some parameters that we're going to put in. Now, again, in practice, this might be tweakable, but I will tell you what you need, or if I don't say anything, leave it at the default. So in this case, our minimum support, we want to see something occur at least 2,000 times before we're worried about it, or else it's just too niche. And then we're only going to be concerned with something that has a minimum confidence of 50%. Now, if you don't remember, what is confidence? Confidence says, if something, then something else. So if that happens, if the then something else happens less than 50% of the time that the if happens, we ignore it. That's not good enough. That's not significant. So we'll throw those out. And if it doesn't happen at least 2,000 times, that's not important. We'll throw that out. And you just click OK.
So don't change nothing.
I didn't change anything. However, oh wait, I was supposed to. Haha! I was like, wait a second. It's very important that you read the instructions. See, I'm trying to make eye contact with you. Normally, that's not something you need to do while you do your homework. Make eye contact with people. Okay, I skipped something. Oh, and it's not 2. Thank you, textbook, for pushing buttons. Okay. We need to change the minimum support to 800.
But you'll tell us in these other positions, another situation, how many change, right?
Yep. It did say in the textbook, but I'm trying not to just stare at it. So that's my mistake. I apologize. This is why I try not to prep for classes on Friday or the Thursday, the week before, because I don't remember by Tuesday. So I always go back and review things. The dean asked me a favor. I got distracted before class. So, aha. Now, it's very important that you start your data on the right spot. Try again, Rob.
So we gotta go back.
Well, hopefully you already did if you're smarter than I am.
So we gotta go back.
Start with data. And then, ideally, Excel's going to crash. You're going to stall for time. Wait for it to recover. Crash for you too? Nice.
So what happened?
I don't know.
Well, should I delete the ones at the bottom?
Sure.
Just start over?
I don't know. My Excel's struggling. Oh, it's recovered. Did yours fix itself? You've lost the Excel lottery today. I won it. Excel fixed itself from an unrecoverable. Count it. We take those. All right, so if you want to delete your old tabs, you can. You don't have to. It'll still run just fine. But we want to change this 2,000 to 800, and that should make all the difference in the world. So change your minimum support number of transactions to 800.
800?
800. Try again.
Is it okay?
Did I miss anything else? 14 rules. That's what I was expecting. Oh, good. Yep.
Things were different in the previous.
Uh-oh, something don't look right with mine.
I changed one thing. The minimum support to 800.
The input data format, you had it set to data in item list format.
That was it glitching. So at first, I had selected this, and then it tried to read it and didn't find a binary matrix, so it wouldn't give me that option. So when I went back to the data, then it gave me the option for the binary matrix format.
Okay.
So that's the one you do want. Binary matrix, 800 minimum support.
Where did you go to add the data mining?
Oh, that's in the add-ins. We're running out of time, so I'll show you in a minute. Okay, what do we see? Okay. So we need a minimum of 800 in our support for this to be worthwhile. So we've got a couple things. We get to see how much is in our antecedent support, how much is our consequent support, and how many times do they both happen together? How many times are they happening at the same time? Okay, so we can calculate
That's what support means?
support. How much does both happen at once? How many total? How many total? How many? So just antecedent, like just looking at antecedent, there's 1,600. Just looking at consequent, there's 1,600 and some change on both. And then there's almost 900 of the support where they happen both at the same time. So, given that there are 881 times that they happen at the same time, but only 1,600, I'm saying it backwards. There's 1,600 that it happened by itself, meaning it happened by itself or with the antecedent, but only 881 times did the antecedent come first. Well, our confidence is not going to be great, right? So, the antecedent happened a bunch of times, but then when the antecedent happened, only about half did the consequent happen, I mean. Right? So, if this, then that, maybe. So if this, there's a 52% chance, 53% chance of the consequent. That's not great, but is it better? So let's look at the lift ratio. We don't know how likely this was in the first place. Or we kind of do, right? 1645 out of 20,000. That's not much. It's like 7 or 8%. So the fact that if this gives us a 50% is actually a really big improvement. 50% doesn't sound like much, but the confidence without the antecedent was only 8% or something. So the fact that we can go from 8%, at a random person, did they visit the website? Well, I don't know. It's like an 8% chance. Oh, but at the antecedent, we've got a 50% chance. That's actually way better. It's way more likely, which is why we have a large lift ratio. So the lift ratio tells you how much more likely is the antecedent to appear, how much more likely is the consequent to appear if the antecedent is present. 6.5 times as likely. Or how about rule 5? If Pinterest, then Amazon. So apparently, if you go to Pinterest, if I know that you've gone to Pinterest, hi Dina, then you are 5.7 times more likely to go to Amazon than if I don't know you've gone to Pinterest. Let me give you another example. If you Bleacher Report, okay. If you have visited Bleacher Report, then you are 5.69 times as likely to have gone to the NFL's website. So, you can look at what these confidence means. Okay, there's a 57.58% chance that if you went to YouTube, you will have also gone to Twitter. So,
And the lift ratio says that the chance you didn't go to YouTube, that was a 6.2% chance you at least went to Twitter. Remember that thing?
no. Lift is a ratio multiplied by the previous number. So, given how likely you are to have gone to it on its own, how helpful is it to know that the antecedent happened? As a multiple. So, if you went to YouTube, then you are 6 times as likely to have gone to Twitter than if I don't know you went to YouTube. Maybe you did, I just don't know yet. If I don't know, then I have a certain percent chance. It's 18 out of 20,000, so it's 8 point something percent. But if I do know, then that jumps all the way up to 57.8% or 0.6%. So, now also the higher support, the more likely it is. Like the more frequently it's happening, the more useful it is. Low supports, they don't happen very often, so it doesn't help. Okay, well, that's all we have time for. So sorry for the technical difficulties. We'll catch you on Thursday.